What's up, math scholars? This is Mrs. Harp here, coming at you with a video about 5.4 day 1. So this is exciting. I hope you're going to follow along. If I get going too fast and you're trying to take notes along with the video, just remember you can always click pause and then resume when you're ready. We're going to start the day off with just some review of how to do factoring. I mean, we did a little bit of factoring on that last quiz, but it's always good to review more because that's what the lesson is going to entail today is factoring. So make sure you click like and leave me a comment. Comments will make me smile. I haven't even gotten one yet. All right, here goes. And of course, subscribe if you have not yet. All right, number 1, we're going to go ahead and use the old-fashioned factoring technique because there is no leading coefficient. So we're just simply brainstorming numbers that would multiply to 30 that would add up to a negative 17. Ooh, beware of the double negative. All right, so our choices are 30 and 1, 15 and 2, 10 and 3, or 6 and 5. Think about what you're going to pick. We should definitely go with 15 and 2 and make both of them negative, because that way we can add up to that negative 17. And of course, multiply to a positive 30. All right, second one, also the old-fashioned factor technique. This time we're trying to multiply to a negative 24, but add up to a negative 10. So we will be going with one positive number and one negative number. I'll run down our choices, see if any of them sound good. 24 and 1, 12 and 2, 8 and 3, or 6 and 4. You thinking about 12 and 2? But we make 12 the negative and 2 the positive, so we can add up to the negative 10. And our last one, we have a special case. This time we have to multiply to a negative 49, but add up to 0. Interesting, huh? I don't know if you remember how these ones work, but you want to go with a positive 7 and a negative 7. You get that number by square rooting. It's called sum and difference of perfect squares. So hopefully that rings a bell. All right, you ready to start the lesson? So it's 5.4, day 1. We're just going to learn how to use factoring to simplify down rational expressions. So we'll have an equation on the top, an equation on the bottom, and we'll be trying to simplify it as much as possible. So before we start, let's just talk about what simplified form actually means. It means that all common factors in the numerator and in the denominator have been canceled out. Now, the hardest thing when you're simplifying down fractions is just to avoid illegal math moves. So I'll give you an example of something that's okay and then something that's not okay, a couple things that are not okay. Let's say that you've done some factoring and your numerator looks like this: x times x plus 1 over x. So something that is okay is just slashing out this x since it appears on the top and the bottom. We have a product on the top, we have a single term on the bottom, we're allowed to cancel it out and have the answer of x plus 1. Now something that would be an illegal math move, let me give myself some space here, would be if you had x minus 5 on the top, it's not a product, it's a difference, x minus 3 in the bottom, and just slashing that x out. That is illegal. That would land you in math jail. So don't do that. Let me give myself a little more space and show you one more illegal math move that I see kids do a lot that is just not something you want to try. So let's say that you factored yourself down. You have x plus 7 over x. You actually cannot simplify that any further. I will see kids trying to slash that x out. That is not allowed because x plus 7 is a sum, not a product. If it had been x times 7 over x, then you could slash the x's out. But x plus 7 over x, no way, don't even think about doing that. So don't do that, it will land you in math jail. So avoid illegal math moves. Okay, so these are going to be our steps we'll be following on all the problems that we simplified today. Step 1 is use factoring, any factoring technique. Our techniques you'll be seeing today are common monomial factoring technique, old-fashioned method, and then we'll even do one with the box method. So hopefully you remember how that works. So once you factor both the top and the bottom, you'll be dividing out common factors and then just expressing your simplified answer. Let's start with this first one. X squared plus 7x over x squared. On the top, the factoring technique you can use is common monomial factoring. So the common monomial I'm seeing that both terms have is an x. In the parentheses, after dividing out an x, I would be left with x plus 7. Now just to keep this simple, on the bottom, instead of writing an x squared, I'm going to write an x times x so you can see what's happening. So right now we have a product on the top and we have a product on the bottom. So we can definitely think about slashing somebody out. It's going to be the x. We can slash this x out with this x, and our final answer would just be what's left. X plus 7 over x. So just a reminder, if you find me going too fast at any time, just click pause. It's no problem. And catch yourself up. Here's our next one. 4x plus 8 over 12. So on the top, we're going to think about using a common monomial. How does 4 sound? 4 is the biggest number that will divide both 4x and positive 8. After dividing a 4 out of 4x, I'm left with x. And after dividing 8 by 4, I'm left with a positive 2. So that completes the top. The 12 I'm just going to rewrite a little bit, just so you can see what's going on. 12 I'm going to write as 4 times 3. Right, I've written it so I have a product on the top, and I have a product on the bottom, so you are allowed to slash out factors that you see on the top and bottom at this point. The 4s can go away. So my final answer is x plus 2 over 3. All right, ooh, this is getting bigger. X cubed plus 2x squared over x squared minus 6x minus 16. Alrighty, on the top we're going to use a common monomial again. Do you know what it would be? What we can factor out of both terms? Go ahead and guess. It's an x squared. That would leave us with an x plus 2. Alright, on the bottom, this is actually the old-fashioned factoring technique that we used in the warm-up. That's why we did the warm-up that we did. I'm looking for numbers that will multiply to a negative 16 that will add up to a negative 6. So I'll run you through your choices. 16 and 1, 8 and 2, or 4 and 4. Hopefully you decided on a negative 8 and a positive 2. So my top is factored, and it's written as a product of two things, and my bottom is factored. It's written as a product of two binomials. Any factors you see that are lining up, you can cross off. So x plus 2 and x plus 2 could be gone, and my final simplified equation is x squared over x minus 8. It's actually a simplified expression. It's not technically an equation. All right, good job so far. Here's our next one. Why don't you pause the video and try this one all by yourself, just for fun. See how you do. Go ahead and click pause. All right, you're back. So, did you use the old-fashioned factoring technique on the top? Go with x minus 5 and x plus 3. And then the bottom was a special case. It factors to x minus 3 and x plus 3. Sum and difference of perfect squares. Looks like our x plus 3's can cancel. So our final answer is x minus 5 over x minus 3. And you cannot cancel anything more there without performing an illegal math move. That might be the same thing we even saw on the illegal math move slide. Yep, it's the same thing. X minus 5 over x minus 3. We're done. Right, if I were you, I would not even bother writing this down. I think they just wanted you to see what can and what cannot cancel on this. It's very simple. I'm just going to watch what I do. I'm going to slash out my x minus 1s on top and bottom, leaving you with a 2 on top and an x plus 3 on bottom. And that's all you can do. Same thing on the next slide. Just watch me do it. You don't need to write it down. So it says simplify the expression if possible. If anything, you might want to maybe try writing the 4 as 2 times 2, but even if you do that, there's just no factor that lives on the top that also lives on the bottom. So the original problem was actually about as simplified as it gets. So if I would do anything, I would just distribute this out and just leave it. But honestly, I probably would have just written can't factor any further and left it how it was at the beginning. All right. Next up, I want you to pause the video and try this all by yourself. X plus 4 over x squared minus 16. Pause the video and try it all by yourself. All right, you're back. So, did you factor the bottom using sum and difference of perfect squares? It will give you x plus 4 for one factor and x minus 4 for the other. Then our x plus 4s live on top and bottom. Now be careful when you express your final answer. You're going to have an x minus 4 in the bottom, but you don't have anybody on top, so you do have to put a 1 there. Kind of, you can't have an empty numerator, you know. And so that's your answer. Next slide. You got x squared minus 2x minus 3 over x squared minus x minus 6. Go ahead and pause the video and try it. You need the old-fashioned factoring technique on top and bottom. All right, you're back. Here's how I factored it. Now we're going to think about who we can slash out. It'd be the x minus 3s. So our final answer is x plus 1 on top, x plus 2 on bottom. And that brings us to our last slide. You've done awesome. We finished this lesson in less than 15 minutes. So I saved the best one for last. Let's go ahead and take a peek at what it looks like. Much bigger of a problem. What makes it hard is that bottom. If you look at the bottom closely, it has 3 terms. It has a leading coefficient of 3, so we're going to have to use the box method on the bottom. Now the top, it's not a box method problem. There's only 2 terms, so it's actually you're just going to pull out a common monomial. Let's go ahead and try the top first. What do you think the common monomial would be that we would pull out of it for both terms? It would be a 2 and an x. That's going to leave us with an x plus 5. The bottom, go ahead and draw yourself a 2 by 2 box. And I'll recap the steps because it's been a while for sure. You take your first term, the 3x squared, and you put it in your upper left box. You take the last term, the 5, and you put it in the lower right box. You go ahead and you multiply the 3 and the 5 together and get 15, and you slash out the 5 and replace it with 15. So now we're brainstorming, how can I multiply to get a 15, but yet add to get a 16? Do you want to go with 15 and 1, or 5 and 3? Definitely want to go with the 15 and 1. So you put the 15 and the 1 in the remaining 2 boxes and give them both an x. And now we just reverse our Punnett square. So we look at the first row, the 3x squared and the 15x. We pull out what they have in common, what could divide both of those terms. It's 3 and x. Then you look at your bottom row, your 1x and your 5, and you pull out what both of them have in common. It's just a 1. Then I just kind of think to myself, 3x times what would give me 3x squared, and I know what will go right here is going to be the x. And then 3x times 5 is 15x. And I just go around now at this point, make sure the Punnett square works. So is 3x times x 3x squared? Is 1 times x 1x? Is 3x times 5 15x? Is 1 times 5 5? And I said yes to all that, so we're done factoring. We have x plus 5 as one of our monomials. We have 3x plus 1 as our other monomial. And it looks like that allows us to slash out the x plus 5. So thanks for watching today. I hope you had fun, and it gave me an opportunity to meet with everybody to discuss what classes they took. They're going to take next year. Your homework is going to be a worksheet. I believe it's just the front side, but I probably gave it to you in class. So I hope you're having a happy Thursday. Hope you had a great snow day yesterday, and I'll talk to you later.